These are the step-by-step solutions for the Calculus BC MCQs Part B with calculator allowed. So let's get started. The graph of f, the derivative of a function f is shown above. The domain of f is on the open interval 0 to d. Which of the following statements is true? 1. F has a local minimum at x equals a. So it's basically saying f prime changes from positive to negative. Negative to positive. At a, we don't have any interval changes. It just remains below the x-axis, so this is false. F has a local maximum at x equals c, so f prime changes from positive to negative. At c, no, because we're still above the x-axis here. We need, if c were having a maximum, and it would go from an interval, from the interval below the x-axis to interval above the x-axis to interval below the x-axis. So that's wrong. The graph of f has a point of inflection at x equals c and y f of c. So let's see. So what this is basically saying is, at this point, f prime changes concavity, which is the fancy word for slope in terms of second derivative. Alright, so is this true? Does our slope change from negative to positive or positive to negative? So we go from positive to negative. So yes, this is true. Let's keep that in mind for now. For letter D, the graph of f is concave up on intervals 0 to a and c to d. So this is basically saying f prime is greater than 0. The slope of f prime is greater than 0, so f double prime must be greater than 0. So from 0 to a, it's not true, because f double prime, the slope of f prime, is decreasing. So no, that already crosses it out. And the graph of f is concave down on the open interval from b to d. No, if it were the graph of f of x, that would be true. But this is the graph of f prime of x. It would only be concave down from 0 to a and c to d. So this is false. So C is our answer. Blood is pumped out of a body at the rate r of t. Let's store that function first. Alright, cubic millimeters per minute, where t is measured in minutes. How much blood is pumped from time t equals 0 to t equals 60? So this is going to be an integral question, 0 to 60 r of t dt. Well, basically, use your y1, and your answer should be D, 173.746 cubic millimeters. That's what I got in my calculator, so this is correct. Moving on. 78. The graph of a function f is shown above. For which of the following values of c is f discontinuous? So it's going to be discontinuous when the graph of f is not where there's like a hole or a jump. So one, look for holes and jumps. So we see one hole here at x equals -2. So immediately we can cross these out. And there's going to be a jump and a hole at x equals 3. So it's going to be 2 and 3, negative 2 and 3. So our answer is going to be D. 79. Let f be a positive continuous decreasing function such as a of n equals f of n. If the series from 1 to infinity a of n diverges, which of the following must be true? Well, if you want to look for something diverges, it should go to multiple numbers. K is going to be a constant, and it's not going to be infinity because it would say infinity, obviously. So this is not going to be true. This function is diverging, so that doesn't, f of x should be diverging. Also converge, we can't, anything that has converge in it, that's not, let's mark that down because it's the opposite. And this one matches it. This one also diverges because it has similar characteristics. So 1, find similar characteristics. And then E, as a of n is approaching infinity, it's approaching a number, which means it converges. So this is false. Moving on. The derivative of the function f is given by f prime of x. Inflection is the graph of f have on the open interval negative 2 to 2. So what we need to look for is a sign change when we're given the graph of f prime of x. So I'm going to graph negative x cubed times sine of 2x. And we're going to have it from negative 2 to 2. And I'm going to graph that. So my graph looks something like this. No, this is not really right. Alright, it should look something like that. And this is f prime of x, which is basically equal. So if you want to find points of inflections, you gotta find the change of slope in terms of f prime of x. If you were given the graph of f of x, you would have to check for the parabola concavity change. So let's look for when f is changing sign. So this, from here to here, f is decreasing up until here. Then it starts increasing up until here. Then it starts decreasing again all the way up until here. Then it starts increasing again. So we have 1, 2, 3 changes of slope or changes in concavity. So there's 3 points of inflection. Points of inflection mean change of slope in the second derivative language. In terms of second derivative fancy language, yeah. Let f and g be continuous from a to b. If a is less than c, which is less than b, the area from a to b of f of x is p, and so on. So let's try to find a to c f of x plus a to c g of x. So let's split this into 2 integrals. All right. So a to c is going to be f of x plus a to c f of x dx. And let's use the info given here. So from a to b, let's split this integral actually. So it's going to be from a to b f of x dx plus b to c f of x dx. I'm literally splitting up this integral into its 2 baby integrals right here, just to clarify with you guys. And then plus a to b. Why did I write f of x twice? It's supposed to be g of x. G of x dx plus b to c g of x dx. Alright? So now, oh, I forgot to write the steps here. 1, store function. 2, graph within domain. then 3. All right. So yeah. So from A to B, f of x dx is represented with P. From B to C, f of x dx, that's going to be Q. Plus. Then from A to B, g of x dx, we're given R, but it's going to be backwards. So we can flip this integral, but just change the sign. So basically, A to B, g of x dx is equal to negative R. That's all you got to do when you have opposite area. You just got to flip everything around. So it's going to be negative R. And then this. Same thing with this. It's going from C to B. We want it going from B to C. So B to C, g of x dx is equal to negative S. Ta-da! And your answer should be P plus Q minus R minus S, which is B. So let me write down the steps for this problem. 1. Split integrals in terms of function. 2. Split integral again in terms of limits. 3. Search for correct function value and flipped integrals with opposite area. And then 4, combine all values together. All right, that's it. Let's move on to this. If this number 82, if this series converges and 0 is less than or greater to a of n is less than or greater to b of n for all n, which of the following statements must be true? B of n over n factorial converges. We don't really know anything about this factorial function. Cross off. Same thing with this 3 to the n. Cross off. Alternating series. That's going to be... We don't know anything about that either. B of n converges. We don't know that because A of n doesn't really say that there's not really direct proportion to A of n and B of n. It's just A of n is either less than or greater to, but we don't really want to take that chance. So we cross that off. None of the above must be true. So that's basically it. So basically your only step here is match criteria. 83. What is the area enclosed in the first quadrant by the curves e to the x minus 1 and y equals cosine of x and the y-axis? So let's graph that. So looking at the first quadrant, you should have something like this. We're going to find the area from here to here. Let's label it R. And this is going to be, we're going to have our point here. And I believe that point is going to be 0.601. So let's set up integral. 1 graph areas to find intersection. Three, plug in to area formula. That's basically it for your steps. Remember that your area formula is going to be from A to B, function, the top function minus the bottom function dx, and let's do it. 0 to 0.601, the top function is going to be cosine of x minus e to the x minus 1, and that's going to be 3.343 as your answer. Very simple. This concludes question number 83. We are halfway done. Now we're moving on to Taylor series. So let f be a function with f of -1, which of the following is the third degree Taylor polynomial for f about x equals 1. So remember that your Taylor series is within this formula. F of n of x, x minus c to the n over n factorial. So let's start with the zero derivative, the original function. So f of -1 times x plus 1, 0, which cancels out, over 0 factorial, which is just 1, which we don't really care, plus f prime of -1 times x plus 1 to the n over, actually this is going to be 1, over 1 factorial, which does absolutely nothing, plus f double prime of -1 times x plus 1 squared over 2 factorial, which is just 2, plus f triple prime of -1 times x plus 1 cubed over 3 factorial, which is just going to be 6. Now let's plug everything in together. So it's going to be 7 plus, you can already do a plug and chug. F of -1, f prime of -1 is going to be 3 x plus 1 plus f double prime of 1 is going to be 0. So that's not going to do anything. And then f triple prime of -1 is going to be -12. And -12 divided by 6, wrong marker, -12 divided by 6 is just going to be -2. So it's going to be minus 2x plus 1 cubed. So let's match everything together, and I believe our answer should be C. And I will write down our steps. So first, identified, whoops. Okay, this concludes the series question. A particle moves on the x-axis with velocity of this function from -3 to 3. How many times does the particle change direction as t increases from -3 to 3? So how many times does the position change direction, because direction is affected by position. All right, so let's look. Your graph should look something like this when your graph is bounded from -3 to 3. We're not going to look at change of slope here. We're going to be looking at change of interval, since we're dealing with position. Remember that this is the graph of v of t. So this is the graph of x prime of t. So using the slope, we got to find the original characteristics of the function of x of t. So we're going to check interval here, and it changes intervals twice. So 2. So 1, graph. 2, look for change in interval. And then we have 4 more pages left. On the graph of y equals f of x, slope of any point of x, y is the square root of x. So dy dx is equal to root x. If f of 0 is equal to 3, what is the value of f of 9? So f of 9, remember that this is going to be the candidate sort of test, is going to be f of 0 plus 0 to 9 square root of x, which is y prime of x, y prime, dx. And then we're going to plug and chug everything together. Which is going to equal, it's going to equal 21. Oh, y prime can be rewritten as root x here. Since you're allowed a calculator, use the calculator to save time. If there's no calculator, you can solve this using anti-power rule. So kaboom, and then kaboom. So what's our first step? Identify question specifics. Then 2. Use candidates formula. Three, plug and chug. Alright. An object traveling in a straight line has position x of t at time equals t. If the initial position is x of 0 equals 18 and the velocity of the object is given by this function, what is the position of the object at time t equals 4? So we're looking for x of 4. So we're going to reuse that candidate's formula, equals x of 0 plus 0 to 4 vt dt. Remember that vt equals x prime of t, so the slope. So this has the fundamental theorem of calculus. So it's going to be x of 0 is going to be 18 plus 0 to 4 vt dt. Plug and chug it on your calculator. You should get 41.631. Boom. Our first step. Apply stuff to candidates formula. Oh, I forgot to write the candidates formula. I'll write that in a second. To plug and chug. So your candidates formula is going to be f of whatever you're trying to solve for is equal to f of given plus given to question mark f prime of x dx. So that's the candidate's formula. Moving on to the bottom ones. For all values of x, the continuous function f is positive and increasing. Let g be the function given by g of x is equal to f of t dt. Which of the following tables could be a value of g? So g here says that f is greater than 0 and f prime is greater than 0. And that means that g prime is greater than 0 and g double prime is greater than 0 because g prime of x equals f prime of x and g double prime of x equals f prime of x. So let's look at the slopes. So from 2 to 0 you're going to go by plus 2, and from 0 to 1 you go plus 1. And then for here, that's the first derivative. So it's going to be g prime of x. As you can see, g prime of x is positive, but let's check g double prime of x. From 2 to 1, you're going down negative 1. So g double prime of x is below 0, not true. From 2 to 0 is going to be positive 2. And from 0 to 3, it's going plus 3. Then you're going plus 1. G prime of x is greater than 0, and g double prime of x is greater than 0. So this is our correct answer. But let's connect the other functions. From 2 to 0, negative 2 to 0, you're going plus 2. Then from 0 to negative 2, you go minus 2. So there is a point where g prime is less than 0, so let's stop. How about here? 2 to 0, you're going minus 2, so let's stop. Can't have any negative slopes. From 2 to 0, same thing, negative 2. Stop there. So our first step, identify vocab and derivatives. Then 2, find matching slopes. Alright. The function f is differentiable for negative 2 to 2, and f of negative 2 equals f of 2 is 5. If f is not a constant function from this domain, which of the following statements must be true? From 2 to negative 2, this is going to be your function. So f of negative 2 is equal to f of 2, which is 5. So let's say that 5 is up here. Predictably, it could be a straight line, but we don't have any points. There's no selected values. So from negative 2 from this domain, the slope of this, this is, by the way, this is f of x. The slope of it is greater than 0. Well, we don't really have any specifics here, so no. Same thing for the next one. We can't find any slope where it's less than 0. So no. For some k, where negative 2k is less than 2, f prime of k is equal to 0. This is true because if you use this value and this value, and you use y2 minus y1 over x2 minus x1, the slope is going to be 0. So from negative 2 to 2, f must have a local minimum or a local max. Once again, we don't have enough info to determine that. So C is our best answer. So 1, graph points. 2, match criteria. Moving on. 3 more questions left. And now we're trying to find the slope of h at x equals 1. So we're trying to find h prime of 1. Let's find h prime of x first. So h prime of x equals f prime of g of x times g prime of x. And now we're going to find h prime of 1, where we plug in 1 to that. So it's going to be f prime of g of 1 times g prime of 1. Let's do a plug and chug. So it's going to be f prime of g of 1 is going to be 2. F prime of 2 times g prime of 1 which is going to be negative 2. So what is f prime of 2? It's going to be 4 times negative 2, which is negative 8. So our answer is A. First step, apply chain rule. Evaluate at x equals 1. Alright? Let f be the function f of x is this, 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 and this. At which of the following values does f attain a relative maximum? So f prime changes from positive to negative, and we're going to graph f prime of x in terms of interval. So f prime, we're going to graph f prime of x. F prime of x is equal to 7 ln of x plus 3 over x minus 5, because using the fundamental theorem of calculus, that is the derivative. So let's double check on that. Let's graph it. So if you graph that, let's see what our graph will look like. Then our domain is from 1 to then your graph should look something like this. That's going to be at 2.877, so your answer is going to be E. Moving on to our last question. We're given this. If b of x equals g times f of x, what is b prime of 1? So let's do chain rule again. Did I write the steps for the other one? No, I did not. So find f prime of x. To graph and find root. Okay? Last one. What is b prime of 1? B prime of 1, b prime of x, is equal to g prime of f of x times f prime of x based on chain rule. Now let's find b prime of 1, which is equal to g prime of f of 1 times f prime of 1. Let's find f of 1 first. So let's say that f of x is this function here. And then let's do g of x is something like this. It's this straight linear. So let's find f of 1. So at when f is 1, our value is going to be negative 1, negative 2, and negative 3. So it's going to be negative 3. So it's going to be g prime of negative 3 times f prime of 1. So the slope here, let's do a slope-intercept equation. Let's look for another point that this graph touches. It's this point. Let's call this x1, y1, which is going to be 3, 0, and this is going to be x2, y2. And this point is going to be 1, negative 3. So it's going to be negative 3 minus 0 over 3 minus 1, which you're left with negative 3 halves. So that's going to equal negative 3 halves. Now let's find g prime of negative 3. Let me change my color. Let's change it to this pastel yellow. Alright. So g prime of negative 3. So 1, 2, 3. Let's find the slope at -3. But remember that g prime of x is, the slope here is always going to be the same. So now we're going to have to evaluate that at any given point. So we could use 1, 1, and this one, -1, 1, 2, 3, 4, 4. X2, Y2, X1, Y1, apply slope. So it's going to be -3 over 2. So it's going to be -3 over 2 times -3 over 2, which you're left with +9 over 4. Oh, I got this one wrong. It's supposed to be +3/2 because the slope is increasing. I got that one wrong. My apologies. So it's going to be positive, and this is going to be positive. So you should get -9 over 4. And that's going to be your answer. And that's going to be question A. This concludes part 2 of the Calc BC Practice Final, Part B, Calculator Allowed. Good luck.